Started.
Started?
Yeah. Upside down, upside down.
Fine. Is it screen sharing?
Yeah.
అది మార్కర్ ఎక్కడ స్టైలస్
Fully charged.
fully charged?
Yeah.
I hope so. It will be helpful now. Okay. Door close చేయనా? Right. Let me see if I am visible to people. Okay. Hello everyone. Good evening. So today I'll continue with this HCV objective questions. So 2 chapters we have completed yesterday. Today I would like to look at least 2 more chapters today, because now these chapters will have more questions. More questions will be there. So yeah, let's start with chapter 3, rest and motion. And how many questions are there in this objective? We have so many. 13 questions are there in that. Objective 2 we have how many? 10 questions. So totally 23 questions in this chapter. So it's a big chapter, important for examination also. Okay, let's start. Let's look at the first question. A motor car is going due north at a speed of 50 kilometers per hour. A motor car is going due north at a speed of 50 kilometers per hour. It makes 90 degrees left turn without changing the speed. Okay. The change in velocity of a car is, okay. So what is the main idea here? Velocity is a vector quantity. Velocity is a vector quantity. So even if you change the direction, you are changing the vector. So direction is changing here, magnitude is same as before. So magnitude of initial velocity magnitude is 5. Initial velocity is 5 magnitude. Final velocity is also 5. Okay, but the angle turned is 90 degrees. Alright, angle turn is 90 degrees. So final velocity is also 5 in magnitude. Now change in velocity, delta V, that will be root over initial velocity square plus final velocity square minus 2 into initial velocity magnitude into final velocity magnitude into cos of 90 degrees. Cos 90 is 0. So this whole thing will become 0. Then you have root 5 square plus 5 square, root 2 5. Root 2 5. Root 2 is 1.414. So into 5. 1.414 into 5. That will be around 70. Right? So if 5 in the sense 15, let's take that 15. 50. So this is going to be 1.414 into 50. Let's say I have 10 here. 50 squared, 50 squared. So what do I get? 50 into root 2 is 1400, almost 70. So 70 kmph is a change in velocity. That means A bit is wrong, D option is wrong. So now between B and C we have to take now. So now we need to look at the direction here. To understand the direction, let me take the same part only, but draw the diagram now. So you have, let's say this is east, this is north. Initially how was it going? It was going due north. Initial velocity was in this direction, right? That is initial velocity for you. And now after that it took a left turn, no? It took a left turn. Hare, what is happening here? I'm not doing anything. So it was going initially like this. Let me rub it off. Okay, let me go there. Pencil is not working. I'll change different color then. Okay. So initial velocity was like this towards north, and after that it went left. It went left. So final velocity is left like this. This is final velocity for you. So we require V final minus V initial. What do? Reverse the direction of initial velocity. Reverse the direction of initial velocity. Initial velocity is reversed, minus V initial. And then find the resultant of that. That is going to be the direction delta V. So what is the direction of it? So this is west. And this is south. It is between west and south. So southwest, that should be the answer. Okay. I hope you understand that. Now let's go to the next question. Figure Q3Q2 shows the displacement time graph of a particle moving x-axis. So instead of saying displacement, okay, displacement also not a problem. Displacement as a function of time, they had given it. So now you see this particular part of the graph you consider. In this particular part, if you see, displacement is not changing. Displacement is not changing, meaning this part is basically corresponding to rest there. So beyond T0 it is not moving. But before that it is going, because x is increasing, and the slope of xt graph is basically dx by dt, which is velocity. Slope is there, you see, non-zero slope is there. So tan theta, and it is acute angle, so tan theta is positive, slope is positive, meaning velocity is positive. Now let us read the options and try to select the option. The particle is continuously going in positive x direction. No, not necessary. So initially it is at origin, okay, but it is going along positive x direction up to T0, but after that it comes to rest. The particle is at rest, that is also not correct, partly correct. It is not at rest from the beginning, It comes to rest after traveling up to T naught. So this is completely not correct. This is also not correct completely. Velocity increases up to T naught, then becomes constant. No, velocity is constant up to T naught. Constant slope meaning velocity is constant. Speed is constant or velocity is constant. In 1D, right, magnitude of velocity is basically speed. Particle moves at constant velocity up to a time T naught and then stops. So that is the answer, you have it. So answer is D option to that. Very good. Now next question. A particle has a velocity u towards east at t equal to 0. Its acceleration is towards west, okay, and it is constant. At x is xa and xb, the magnitude of displacement in the first 10 seconds and then on the next 10 seconds. Then, okay. So what is he saying? Velocity was in x direction, but acceleration was in negative x direction. So what will happen initially? So displacement in first 10 seconds, let's write it. In the simplest possible way, we'll write xa equal to, xa will be, in a very mathematical way we'll do it. xa will be equal to u into 10 minus half a into 10 square. So that is going to be 10u minus 50a. So that is xa. Okay, equation 1. Now xb will be displacement from 0 to 20 seconds, total displacement you calculate. Displacement from 0 to 20 seconds. Come on, man. I need to change the stylus here. Minus displacement from 0 to 10 seconds. 10 to 20 I require, no? First you calculate 0 to 20 total. Out of that 0 to 10 you remove it. You will get xb there. So what is xb? So 0 to 20 would be u into 20 minus half a into 20 squared. And that is displacement from 0 to 20. Minus 0 to 10 is nothing but xa, no? xa is how much? 10 into u minus 50a. Okay, let's calculate xb now. So xb equals to, here you get 20u and here you get 10u. 20u minus 10u would be 10u. Okay. Come on, man. Okay. Here you will get how much? 400, na? 400 by 2 is 200. Minus 200 plus 50, meaning minus 150. This is what I have. This is second equation. Now which is more we have to calculate. Let's calculate xa minus xb. xa minus xb. xa is how much? 10u minus 50a, and that is xa. xb is how much? u into 20. want to tell that way, yeah. Okay, let's do one more thing. What we do is, we'll just take the ratio. It's very intuitive, but still, let's calculate the ratio of it. XA by XA by XB, that is 10U minus 50U, 50A. Divided by 10U minus 150U. This can be written as 10U minus 150A plus 100A. I'm writing it like this. 50 I am writing it as 150 minus 100. You will get this as 1 plus what is this, man? Are there anyone? Mr.Frames, is it? Yeah. Three 01727. I'm just trying to understand whether you guys are go live. What is going on? Live meaning something else is coming here. You guys are also watching, is it? Why is it not going? Get set up to live stream now. Don't worry, you will have a chance to review settings before you are live. Streaming software, built-in webcam, no. Where is this streaming going, yaar? Is the streaming going or not? Cyril, ఏంటి స్ట్రీమింగ్ జరుగుతుందా అసలు? Could you identify going on? YouTube?
I'm not looking at the stream.
I think it's not going.
I'll check. Yeah, it's working.
Huh?
It's working.
Working?
Yeah.
But why I'm not able to see? Any viewers are there?
No, only me.
Can you see my software, anything that I opened already? ఇది రావట్లేదుగా. Oh, it came, is it? Can you see my software, anything that I opened already? Any viewers?
No, only me.
ఇది రావట్లేదుగా. Oh, it came, is it? సరే. So I'll continue. Huh? Okay, right then. Carry on. Right. So what am I getting here? This will be equal to. This will be equal to. One plus come on, man. This is how it works. Okay. Now you see it works properly. Yeah. Very good. So for this to be greater than 1, if XA has to be greater than XB, for example, then what is the condition? This extra term we have now, that has to be 100A upon 100U minus 150A has to be greater than 0. So anyway, numerator is greater than 0, the denominator has to be greater than 0. What does it mean? 100U has to be greater than 150A, or U has to be greater than 3/2A. So if this condition is satisfied, then XA will be greater than XB. And if it is not satisfied, then XA will be less than or equal to XB. So I cannot tell, information is not sure. Depending on the value relation between U and A, we can decide. That means the answer has to be D. Answer has to be D. Information is insufficient. It is decided only based on the relation between U and A. So that's about the question there. Okay, next question. A person traveling on a straight line moves with a uniform velocity v1, okay, for some time, and with uniform velocity v2 for the next time interval. Average velocity is given by. Okay, average velocity, what is the formula? These are all very important relations. Arithmetic mean you should remember it, but anyway, how do we derive it? So V average is basically total displacement upon total time. Total displacement upon total time there. Displacement is how much? V1. With a speed v1 it travelled t0, let us say, and again with a speed v2 it has travelled t0. So the total distance by total time is 2t0. You see t0, t0, t0 gets out, and then you have option A correct. Right, arithmetic mean, equal time interval, arithmetic mean, equal distances, harmonic mean you will get. That is something you need to memorize it. Okay, next. A person traveling on a straight line moves with a uniform velocity v1 for a distance x and with a uniform velocity v2 for the next equal distance. The average velocity is given by, I was talking about that now. Here you will get harmonic mean. Let's see how it is. Total time. Total time that we get here. Total time equal to time for the first journey plus time for the total second journey. Total time can be written as total distance. Let's say 2x is the total distance covered. They said equal distances, no? First journey x distance, second journey x distance. Total distance is 2x. So 2x is the total distance by V average. That will be equal to x by v1 plus x by v2. If you go with the common velocity for the entire journey 2x, what is that common velocity, average velocity, so that it gives the same time. You see that x get cancelled everywhere, and you will get what? 2 by V average equal to 1 by v1 plus 1 by v2. Option C is the answer. Okay, next. Okay, a stone is released from an elevator going up with an acceleration A. The acceleration of the stone after the release is. Very good question. Pause here and tell me what is the answer they are talking about. See here, whenever this elevator comes, right, immediately what is the idea we get here? Relative motion. So we'll get relative acceleration. That's what you would have got. You also would have got that idea because elevator is mentioned, or so escalator or elevator, whatever. So elevator is mentioned in relative acceleration. But smartly this question was asked acceleration, not relative acceleration. They asked acceleration of the stone. They didn't say with respect to elevator, they didn't mention. So that is the catch here, word catching. They will show elevator, but they are not asking relative acceleration. Just to distract you, they mention elevator, but they are asking acceleration. So here the concept they are trying to test is, if not mentioned, you take a reference frame is ground only, surface of the earth, right? If not mentioned, you should take the reference as surface of the earth only. I mentioned elevator, okay, I mentioned some other car, I mentioned some other helicopter, aeroplane, okay, but if I don't mention reference frame, the reference frame is assumed to be ground only. So with respect to ground, if you are observing, meaning elevator is going up but observer is on the ground, the observer is observing from the ground, if he observes the particle there, which is going to, so many times I am mentioning the observer, so if you release it, the particle will experience only gravitational force. Pseudo force will not be observed because observer is on the ground. So pseudo force is based on observer, no? Observer is on the ground, meaning there is no pseudo force, only gravity is there. So the acceleration will be g downward. The same question if I change it a little bit. Suppose observer is in the elevator. With respect to elevator, if they say, then you need to apply pseudo force. So what will be the pseudo force? Elevator is up, pseudo force will be downward. Then g plus a. G plus a would be the acceleration with respect to elevator. But with respect to ground, g only. Anyway, now sixth question is over. Now seventh question. A person standing near the edge of the top of a building throws two balls A and B. Ball A is thrown vertically upwards, ball B is thrown vertically downward at the same speed. The ball A hits the ground with a speed VA and the ball B hits the ground with a speed VB. Then, okay, this is a good conceptual question. So, how do we solve it? I want to solve it in two methods. Method one is kinematics. So, v squared minus u squared equals to 2as. V squared minus u squared equal to 2as. So, in this method, what is s here? In first case, what is s? What is s in the second case? Particle is projected upwards. Then what is the displacement? Particle is projected downward. Then what is the displacement? Displacement in first case, displacement in second case. See, when you are looking at displacement, you only worry about one initial position and final position. In between, what happens, I don't care. It goes up and comes down, or it goes down directly, doesn't matter. Where was it initially? At the top of the building. Where is it finally? At the ground, on the ground. So the displacement is minus h in both the cases. Displacement is how much? Minus h. How, sir? Minus h? Yes, sir. Independent of path, sir. Displacement is only dependent on initial position and final position, and that is why. So displacement is same in both the cases, minus h and minus h. Very good. What about acceleration in both the cases, a1 and a2? Same only, minus g and minus g only. Acceleration is decided by gravity. You move or you don't move, or you drop, you throw horizontally, throw vertically, at any angle you project it, gravity is going to be always vertically downward. So acceleration due to gravity would be always vertically downward, irrespective of how you project it. So acceleration is also decided. What about the initial velocities? Initial speeds, velocities are different, but initial speeds, if you calculate, only magnitude of initial speed, if you calculate, because square we are doing, no? In that case, both of them are going to be same only. So that means in both the cases, magnitude of u is the same, magnitude of a1 is the same, s1 is the same, acceleration is same, displacement is same. So all RHS terms are same. That is why VA must be equal to VB. VA must be equal to VB. This is one method. This is simple method we are using. Just a kinematic equation, because kinematics chapter, no? This is one method. What is the other method we can go for? The other method that we can go for, anybody, can anybody suggest the other method? So I call that method as, what do I call? I call it as COME. Conservation of mechanical energy. COME. So initial kinetic energy. First case you calculate, it is half mu square. First case you calculate, it is half mu square. Second case you calculate, it is half mu square. In both the cases, initial kinetic energy is same. Initial potential energy. First case you calculate, it is mgh. Second case you calculate, it is mgh, because in both the cases the particle was at the top of the building only. And now final potential energy. First case it is 0, second case also it is 0, finally it is coming to the ground only. Then they are asking about final kinetic energy. So initial kinetic energy plus initial potential energy is equal to, right? Initial kinetic energy plus initial potential energy is equal to final kinetic energy plus final potential energy. In both the cases, initial kinetic energy is same, initial potential energy is same, final potential energy is same. So final kinetic energy has to be same only. That means both half mv square must be same, half same, m same, v must be same. Answer is C, VA equal to VB. That's answer. Very good conceptual question. I hope you understand it. Let's go to the next question then. In a projectile motion, the velocity is always perpendicular to acceleration. Why? Projectile motion, you project it vertically upwards, it is not perpendicular, it is 180 degrees going up, 0 degrees coming down with respect to acceleration, not necessarily perpendicular. Is never perpendicular? No, not necessary. You projected horizontally, at the time of horizontal projection, their velocity is horizontal, acceleration is vertical. It can be perpendicular. In fact, you take a oblique projectile, at the highest point velocity is horizontal, acceleration is vertical always, angle is 90 degrees, so it can be perpendicular. Never perpendicular is also not correct. Is perpendicular to acceleration for one instant only? Perpendicular to acceleration at one instant, that is true only at that moment, correct only. Is perpendicular to acceleration for two instants? Where is two instants? No, only at the highest point you will have it. So answer is C, sir. Answer is C. I think this is a simple question only. Okay, next, 10th question. The range of a projectile fired at an angle of 15 degrees is 50 meters. If it is fired with the same speed at an angle of 45 degrees, its range would be, okay, range formula based. What is the formula for range? U square sine 2 theta by G. So basically proportional to sine 2 theta. Remaining all leave it, just focus on theta. Theta only they are talking about, right? So R2 by R1. Will be equal to sine of 2 into 45, meaning sine 90 degrees, divided by sine of 2 into 15, that is sine 30 degrees. You will get what? 1 by sine 90 is 1. Don't worry, there is a little problem in the stylus. I will be just tapping on it. You will get 2. So R2 equals to 2R1. So obviously R2 is greater than R1. R2 is greater than RB is greater than R1. So what is the answer? Option A. Okay, next. A river is flowing from west to east. For me, this is east and this is west. This is west. Correct one. Sun rises here this way only. East to west. Okay. It is going from west to east. It is going in this direction at a speed of 5 meters per minute. A man on the south bank of the river, capable of swimming at 10 meters per minute in still water, wants to swim across the river in the shortest possible time. He should swim in a direction. Okay, so here concept is what? Here concept is velocity in x direction cannot produce displacement in x direction. Sorry, what did I say? Velocity in x direction cannot produce displacement in y direction. Velocity in y direction cannot produce displacement in x direction. So two mutually perpendicular direction. Y direction velocity is due to only y direction displacement and all they are connected. X direction velocity and x direction displacement. So x direction velocity cannot produce y direction displacement, y direction velocity cannot produce x direction displacement. That mutual exclusivity is there. So now let me draw the diagram. Let's say this is a river flowing like this. So this is west and this is east. So this is south. So one boy is over here. Now he wants to cross the river in the least possible time, you see, shortest time. So I will take this as x-axis, east tide I will take it as x-axis, and north side I will take as y-axis, positive y-axis. Okay, now the person will be, let's say, trying to swim in some angle like this. Is trying to swim like this. So when he is orienting himself like this, right? Orienting himself like this, what color should I use? Let's say he kept his hand like this. This is the body, hands, legs and all. Okay. So he is giving velocity like this. This is a swimming velocity. Let's call it as V naught. You resolve it into components. You have Vx. See, it works well. And then you have Vy like this. Alright, but river is also going with u velocity. River will push him with u velocity. Only because of swimming, Vx, Vy. Because of the river push, u extra. So the net velocity in x direction if you consider, that will be Vx plus Vx plus u. Net velocity in y direction is how much? Only Vy. Right. But we know that root over Vx square plus Vy square, is equal to V naught. That is swimming speed. That is constant. That is your capacity. How hard you can swim. Alright? That is going to be constant. Now, let's say this is displacement in y direction, na? That is river width. Displacement in y direction is width of the river, d. And that is equal to velocity in y direction into time taken. So I want the time taken there. So change the color, yeah. Red color is not good. Is it red color only? Yeah. Time taken will be equal to d by Vy. Now you want to minimize t, so maximize Vy, keep on increasing Vy, until Vy equal to V naught, Vx equal to 0. That means if you want to go with the least possible time, you need to orient yourself, not like this. This is wrong general situation. So how should you orient it? I'm assuming that you know this idea. So you are going to orient yourself perpendicular to direction of river flow. This is how you need to orient yourself. Swim in this direction with this maximum possible speed that you have. Of course, you will not go right across. River is not just waiting for you to go in that direction, but its objective is not to go to across there. You will go at some other position, that's okay. But you want to minimize the time, na? If you want to minimize the time, you need to cross the river perpendicular to river flow with the maximum possible speed. Then you will have the minimum time there. You will have a drift, sideways it is going to be pushing you. You will go like this. You are orienting like this perpendicular to river. You are orienting like this perpendicular to river. But you don't go perpendicular to river. You will go like this. But our objective is not to go right across. Just cross least possible. Probably somehow you want to go to the other side. Imagine that this side you have a enemy country. Alright. Somehow you got landed in enemy country because of some flight accident or whatever it is. And the enemies are coming towards you to catch you. They are throwing bombs at you. You want to somehow cross the river, that's all. Wherever you reach doesn't matter, but at the least possible time. Right? It starts swimming right across. You will reach the other side. Don't reach the other side exactly opposite. Somewhere you will reach. That's not a big deal. But you need to cross it, that's all. At the least possible time. That's the basic idea here. Okay. Now, what is the answer? Due north. Due north is the answer there for this. Very good. Now, 13th question. So, last question in objective 1. In the arrangement shown in the figure 3-Q3, the ends P and Q of an inextensible string move downward with a uniform speed u. So, P and Q are moving down with uniform speed u. So, this is coming down with uniform speed u, and this is u, and this is also u. Then they are asking you to find the speed of m there. Alright, so what do we do? How do we do it? I want to solve it. So I want to solve it in the easiest possible way without using differentiation. Or shall we use differentiation there? Shall we use differentiation? Okay, we'll do it in two methods. Let's see. So first method, differentiation method, let us do. So what I'll do is I'll just drop a perpendicular like this. Imagine this is y, this is some L. Okay, and this is L1. Let's write it as not LA, for example. This is L2. So total length of the string, if I calculate, L total, L1 plus L2, 2 times, because left side and right side, same length, na? This is L1, this is L2, L1 plus L2, 2 times, right side and left side. Okay, that has to be constant. This is constant, sir. Change the color, this is constant. Okay, when this is constant, then 2 is, when we take it off, so L1 plus L2 has to be constant. L1 plus L2 equal to constant. So okay, now you differentiate it. dl1 by dt plus dl2 by dt equals to 0. Very good. Now dl1 by dt is simply u. We have it. L1 is increasing because this guy is pulling like this with velocity u. L1 increases because of u. dl1 by dt is u. That done. L2 is at some slant end, but the block is going up there, so they are not directly related. We have to write L2 in terms of y. So what we do is we'll write L2 squared equals to a square plus y square. Very good. Now you differentiate that part. So you will get 2 into L2 into dl2 by dt equal to 0 plus 2y into dy by dt. I hope you understand that. y0, a square is constant, na? So 2 gets cancelled. I'll get dl2 by dt equal to dl2 by dt equals to, so what do I get? 2 gets cancelled. Y upon L2 come on man, into dy by dt. Dy by dt is velocity of small m, capital M there. So y is the depth of this capital M, so this is V we are talking about. So I'm hitting so hard. Probably it will make you also alert. Yeah. Our teacher used to hit us so badly. Just like that, even without mistake also. Even if he's very happy also he hits. So getting used to that hitting was very tough. So, but he smiles all the times. Chadak with the kara. Okay. So y by L2 is how much? Y by L2 is nothing but cos theta. So this is basically y by L2 is what? Cos theta, no? Adjacent side by hypotenuse, you can see that. Adjacent side by hypotenuse. Right, so cos theta into V. Substitute there. This is u plus V cos theta equals to 0. Otherwise, V equals to minus u by cos theta. What is the meaning of minus there? Some minus problem had come. Why did it come? Because dy by dt is not v. dy by dt is minus v. Why minus v? Because y is decreasing. So then it will become false to say, don't worry about it. So what do I get? V equal to u by cos theta. This is one method, sir. This is one method using differentiation. I hope you are okay. Simple, initially it will appear very complicated, but over a period of time it becomes so easy. If you have difficulty in this question, right, forget about what other people think. Take this question again and again, again and again, again and again. Differentiate, solve it. Differentiate, solve it. Differentiate, solve it. 4 times, 5 times, 6 times, 10 times you do it. Until that time it becomes easy for you. So that way you need to tackle anything tough. If you feel tough, right, it means it needs repetition. If you feel something is tough, what does it mean? You need repetition. That's all, nothing else. Whatever you feel tough, right, it appears to be, it is just that it is telling you please repeat. That's all. Just follow that one thumb rule, everything will be taken care of. Okay, sir. So that is method 1, sir. Now I am going to go for method 2. Okay. So what I'll do is I'll take only one part of the string. Which part of the string should we take? Should we consider the right side part of it or left side part? Let's say right side part of it I'll consider. This part I'll consider. Let me draw the diagram over here. So you have this one, yes, this is going down with velocity u, and this is going up with velocity v, and this angle is theta. Now what we do, resolve the velocities along the string and perpendicular to string, along the string and perpendicular to string, along the string, perpendicular to string. V cos theta in this direction and V sin theta in this direction. V cos theta, V sin theta, V cos theta, V sin theta. Now focus on only those velocities which are along the string. Only those velocities which are along the string. Focus only on those velocities which are along the string, because only those velocities can change the length of the string. U this side and V cos theta in this direction. So I use that color, different color. That's why I think we are not able to write it. So next time when I am coming to this, I'll make sure that the stylus works better. So now you see the rate at which one end approaches, that is V cos theta. The rate at which the other end goes away is U. So V cos theta has to be equal to U. V cos theta has to be equal to U, because the length between them is constant. This part of length is not going this side. It is just going up only. This part has to be constant. And that means V equal to U by cos theta. This is other method, we have it. Okay, there is one more method called virtual work method. I will stop it here. We will do it after some time. Okay, anyway, objective 1 we have completed, 13 questions completed. So I hope you are all comfortable. Any doubts, any concerns, or any things you want to ask me? So I just want to, what is this? This is with G. So I will go with the other one where I can use. Alright, something is coming here. I want to see my how do I go? You see, my son is helping me going through. So my videos, I want to look at, oh, sign in I have to do, Mr.Frames. So are you able to see the password? I think I missed at the rate of. I hope I am correct this time. Continue, man, continue. Hi, Mr. Frames. I hope the name is okay for you guys. Hmm? So where do I look at my views? This is Brent Riveria. Somebody's. Okay. It opened. Yeah, what to do? Huh? So where is my live show? I don't know. This is history. How can I watch my own? Is it possible to watch my own? I think I'll have to go here. YouTube Studio. Yes, I got it now. Looks like there are 3 views here. Current subscribers 4. Today 1 subscriber had increased. Yesterday there were only 3. So today total video top videos HCV objective solution 7. Okay, recent subscriptions. I've seen somebody. Okay, totally I got 4 subscriptions, ma'am. Thank you, ma'am. Okay, average view duration only 32 seconds. Okay, right. Hope people will get to know and they'll be able to go through it better. Anyway, let's move on. So now let me go through the remaining part of the questions. Objective 2. Right. Shall we do? This is going to be 1 or more than 1 answer questions. Let me solve. Consider the motion of tip of a minute hand of a clock. In 1 hour the displacement is a minute hand, the big one. No? So let's say 12 o'clock. It will be exactly at 12. Then 5 minutes, 10 minutes, 15 minutes, and then half an hour, and then 45 minutes it comes here, then 1 hour it comes back to here. So it comes back to the same position, meaning what is the displacement? 0. Displacement is 0. Displacement is 0, correct? Very good. The distance covered is not 0, that is 2 pi r. Average speed is not 0 because average speed depends on distance. Average velocity is 0 because displacement is 0. Average velocity will be 0. So A and D is the answer. Very good. Now option second question. A particle moves along the x-axis as they had given some expression. They had given ut plus a into t by 2. The initial velocity of the particle is u. So velocity they are asking. First you differentiate with respect to time. Dx by dt. Let's calculate first. U into t differentiation is 1, 2 differentiation is 0. Okay, that is over. Next we have the other one plus a into t minus 2 whole square. So differentiation of that would be 2 into t minus 2 into 1 minus 2 differentiation is 0. Okay, so what do I get then? U plus 2a into t minus 2. This is what I get. This is what I am getting, sir. Now they are asking you to find initial velocity. Initial velocity meaning put t equal to 0. Velocity at t equal to 0 is called initial velocity. Initial velocity. Initial velocity is velocity at t equal to 0. So what am I getting? You will get u plus 2a into 0 minus 2. So what am I getting? U minus 4a. Oh, that's answer. Initial velocity is not u. Wrong. So you don't confuse with ut plus half a d square. It is slightly different. It's written almost the same way, but it is not the same. So just go with the definition. You gave a position, differentiate with respect to time, you will get velocity. Initial money put to equal to 0. Now the acceleration of the particle. Okay, So what do I do? We can further differentiate it. First let's write v equal to u plus 2a into what the hell, man. 2a into t minus 2, no? Acceleration meaning differentiate. Acceleration I will write as AC because this A is under AC, the acceleration you may get confused. This is dv by dt. Differentiate, sir. U differentiation is 0 because u is constant, plus 2a into t differentiation is 1, 2 differentiation is 0. So acceleration is how much? 2a, not a. So B option is also wrong. B is wrong, sir. Acceleration of the particle is 2a, correct. And the particle at t equal to 2, the particle is at origin. At t equal to 2, the particle is at origin. So put t equal to 2 here. T equal to 2 meaning this is 0, this is 0, this is 0. Overall 0 meaning x is 0, correct. Substitute t equal to 2 seconds and see where it is. Correct? Very good. Okay, so there are other ways of comparing and doing it, but I'll just leave it there. Just let's simplest way, mathematically differentiate equate to 0, that you should be comfortable. Sir, don't say I'm mathematically not that if you are not comfortable, repeat it. Repeat 2-3 times. Just remember only one rule of thumb. If you are not comfortable, repeat it again. Until you are comfortable, repeat it. But with some thought process, don't blindly repeat it. Try to understand what is happening, why it is happening, and then slowly keep doing it, keep repeating it. 2-3 times you do it, you will get it. Don't worry about it. Okay, next question. Pick the correct statement. Third question, sir. Average speed of a particle in a given time is never less than the magnitude of average velocity. Correct, sir? That is correct only. This is a very important statement you should know. Alright. Displacement is never greater than distance. Displacement at the maximum, it will be equal to distance in magnitude, but it will never be greater in magnitude. So when displacement is related to average velocity, distance is related to average speed. So average speed is always greater than or equal to average velocity for any time interval, for any path you consider. So what is the answer then? Why is this coming here? Don't say. Huh? That word file itself is gone, is it? Okay, anyway, don't worry. I think it is there. So we were in objective 2, is it? Those things, the writing part is gone. It's all right. Not a problem anyway. Where were we? Yeah. So the average speed of a particle in a given time is never less than magnitude of average velocity. This is very important concept. See, don't try to mug this up. I want that you should get the feel of it. Why it is so, you need to get the feel of it. If you are not getting it, think about it, do experimentation, whatever it is, but you need to be thorough with that statement. Average speed has to be greater than or equal to magnitude of average velocity. Distance is always greater than or equal to magnitude of displacement. Okay. So here you see B option, mod function they had given, but smartly they had given. So in the first option they had given, first dv bar by dt is done, then mod they have taken, meaning first dv bar by dt meaning acceleration. dv bar by dt is acceleration. So magnitude is taken later. First derivative, then magnitude. Okay. First derivative, sequence is important here. First derivative is done, you get acceleration, and then you take a magnitude. That's all right. But here what is it doing? First he is taking magnitude. When you take magnitude, you are getting speed. Magnitude of velocity is speed. Rate of change of speed is not acceleration. Rate of change of speed is not acceleration. Rate of change of speed is tangential component of acceleration. Only tangential component of acceleration. In 1D motion both are equal, but in general, if you go for 2D motion, rate of change of speed is different from rate of change of velocity. Anyway, it is possible to have a situation in which acceleration is not 0, but speed is constant. Yes, uniform circular motion. Uniform circular motion, you see speed is constant. So rate of change of speed is 0, tangential acceleration is 0, but velocity changing not because of the change in magnitude, but because of change in direction. Zip, like this it turns. Direction changes also, velocity changes. Meaning it is possible, sir. A, B is also correct. The average velocity of a particle is 0 in a time interval. Average velocity is 0 in a time interval. Average velocity is 0 in a time interval, he is saying. V average is 0. Okay. But what is the definition of V average? What is the definition of V average? It is displacement upon time interval. So displacement upon time interval 0 meaning displacement is 0. Okay. Displacement is 0. That much we got it. So what? Now let's read the next remaining part. It is possible that the instantaneous velocity is never 0. Yes, possible. Displacement is 0. You went like this and came like this and again came back to the same initial position. If you come back to the same position, that is enough. Howsoever you are moving, that doesn't matter here. So that means it is possible that you can continue to move, but you have 0 displacement, and so you have 0 average velocity. Very much okay, sir. Very much okay. C option is correct. Next, D. The average velocity of the particle moving on a straight line is 0. Average velocity of the particle moving on a straight line he had mentioned. Moving on a straight line he had mentioned. In the previous option they didn't mention straight line. That's why I have taken curvilinear path. It is possible that the instantaneous velocity is never 0 in the interval. So it is going like this and then it is going to turn back. No? It is going like this and then turn back. So whenever it is going like this and turning back, that point of turning there, velocity has to be 0 momentarily. It has to come to rest and then become reverse. Positive velocity to negative velocity, it has to turn, meaning in between it has to go through 0 momentarily. So velocity cannot be constant there. Velocity has to change. Velocity will become 0 at some interval. It is possible that instantaneous velocity is never 0, that is wrong. Instantaneous velocity has to be 0 at the point of return, that too in the case of 1D. This is very important conceptual question. Don't treat them as questions. These are all concepts. That's why HC Verma book is very important for us for understanding concepts. If you want to revise the concept in kinematics, don't look at the theory reading, right? Theory questions you have to practice. Okay, go on to the next question there. Next. An object may have varying speed. Speed is changing, meaning you are putting the accelerator on, otherwise applying the brakes. Okay, without varying velocity. How is it possible, sir? Velocity is basically what? Velocity is what? Velocity equals to speed into unit vector. So speed is magnitude, unit vector is direction. So you change the speed, then also velocity changes. You change the direction, then also velocity changes. Both of them are changed, then also velocity changes. So he is saying speed is changing, meaning definitely velocity is going to change. Without having varying velocity, not possible. Not possible, sir. Not possible. Okay, this is wrong. Varying velocity. So velocity is varying. Second case is saying velocity is varying. How is it varying? He didn't mention. Is the speed varying because velocity is varying? Is the direction varying because of that it is varying? He didn't mention. So varying velocity without having varying speed, that's pretty much okay. Don't change this. You change this, then also velocity changes. So velocity equal to speed into v cap. Remember this and you can understand it very easily. Non-zero acceleration without having varying velocity. How is it possible, sir? Acceleration meaning what? What is acceleration? What is acceleration? Rate of change of velocity. So velocity is not changing, it seems. That means rate of change of velocity is 0. That means acceleration has to be 0 only. So that is wrong statement, sir. Wrong statement. Non-zero acceleration without having varying speed. Possible. Velocity has to change. Speed need not change. Velocity has to change. Speed need not change. Please understand that. You are a physics student. You should understand the difference between velocity and speed. Velocity has to change for you to have acceleration. Speed may change, may not change. What does it mean? Direction changing, that is also enough. So non-zero acceleration without having varying speed is possible. That is okay. So answer is B comma D. B comma D. Are these questions or concepts? concepts. Okay, fifth question. Mark the correct statement for a particle going on a straight line. If the velocity and acceleration have opposite sign, velocity is one direction, acceleration is another direction. Or maybe velocity in upward direction, acceleration is downward direction. Otherwise velocity is up the incline, acceleration is down the incline. Or otherwise reverse also. They are opposite to each other. Whenever they are opposite to each other, speed will decrease. It is going to slow down. Velocity and acceleration have opposite sign, means object is slowing down. Perfectly okay. Position and velocity have opposite sign. The particle is moving towards the origin. Yeah, so V bar equals to dr bar by dt. Okay. Straight line path, na? Straight line path. Only x direction, let's say. If it is going away from origin, x increases. If it is going towards origin, x decreases. So yeah, so you have position vector like this. Let's say this is position and velocity is in opposite direction. Possible? X will decrease as it is coming. Otherwise, let's say position is this way. Velocity have, the particle is moving towards origin. Velocity is in opposite direction. So then also it is approaching origin. Right? Origin is there. Okay, fine. So option B is correct, sir. Velocity in opposite direction to position vector, meaning it always approach origin. This is also important concept. Velocity is 0 at an instant. Acceleration should be 0 at that instant. Why? Not required. Not required. Example. Can you give me example? Velocity is 0 at a particular instant, but acceleration is not 0. Counter example we want to give so that it can be avoided. Velocity is 0. Right now velocity is 0. Next moment velocity can change, no? Next moment also velocity 0, meaning it is not having acceleration. But right now it is stationary and next moment it will change. Possible. Example. Car is stationary right now. Racing car starting. On your mark. 1, 2, 3. Then you apply forces. Like that. Next moment it gets velocity. But at the time of starting you are supposed to have 0 velocity. Otherwise you will be disqualified. So you have 0 velocity but you had acceleration, that's why you are able to move forward. Otherwise you throw a particle vertically upwards like this, it goes up, 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 up and highest point velocity will be 0, then it is going to reverse back, but throughout the motion it has got gravity acceleration. So velocity is 0, acceleration need not be 0. The relation is not direct, it is differentiation relation. If one function is 0, its differentiation need not be 0 at a particular point. So that is one thing. So velocity is 0, acceleration should also be 0 at that instant, not necessary. Not necessary. You see, beautiful conceptual questions. Beautiful conceptual questions. Alright, everybody should look at them. Okay. Velocity is 0 for some time interval. Velocity is 0 for some time interval. Meaning that interval particle is not moving, stationary. The acceleration is also 0 at any instant within the time interval. Yes. Velocity 0 now, next moment also velocity 0, meaning no acceleration. Next moment also velocity 0, meaning no acceleration. Next moment also velocity 0, meaning no acceleration. So throughout that entire interval where the velocity is not changing, 0 or not 0 doesn't matter, not changing during that interval. And that is why it has got 0 acceleration within that interval. That's correct. So the answer is also correct. D option is also correct. Okay. Next, sixth question, sir. The velocity of a particle is 0 at t equal to 0. Okay, momentarily 0 he said. Will it continue to be 0 throughout or will it go afterwards, or we don't know that. But at that moment velocity is 0 momentarily. Acceleration at t equal to 0 must be 0, just now we have seen a wrong statement. Velocity 0 does not mean acceleration has to be 0. Acceleration at t equal to 0 may be 0, correct statement. May be 0, may not be 0. Acceleration is 0 from t equal to 0 to t equal to 10 seconds if the speed is also 0 in this interval. Yeah, speed 0 meaning velocity is already 0, speed 0, it is not changing velocity, meaning acceleration is not there during that interval. If the speed is 0 from 0 to 10 seconds, the acceleration is always also 0 in that interval. Correct, sir. Acceleration 0, velocity does not change. Velocity does not change meaning already it is at rest. So it will continue to be at rest only. Okay, very good, sir. So what is the answer? B, C, D. Next. Mark the correct statement. The magnitude of velocity of a particle is equal to its speed. Magnitude of velocity of a particle equal to its speed. Very important conceptual questions, sir. These are all very important conceptual questions. Correct, sir. This is correct. Magnitude of velocity of a particle is equal to speed. When we say this, now it is instantaneous. Instantaneous is understood, default. They need not mention that it is instantaneous or average. Sir, they didn't mention it is instantaneous. I to take as average. No, that's wrong. If they don't mention, you should treat it as instantaneous only. Okay. The magnitude of average velocity in an interval is equal to its average speed in that interval. Not required. That will happen only if it is 1D motion, and that too going in one direction, not changing the direction. So whenever you change the direction, distance will be different from displacement, and so average speed will be different from average velocity. That's a wrong statement. Okay. It is possible to have a situation in which the speed of a particle is always 0, but the average speed is not 0. It is given, it is possible to have a situation in which the speed of a particle is always 0, but average speed is not 0. No, not possible. Speed 0 meaning not moving. Not moving meaning distance covered is 0. When distance covered is 0, average speed, distance covered by time taken is also 0. That is also wrong. It is possible to have a situation in which the speed of the particle is never 0. So it is continuously moving, but the average speed in an interval is 0. That's wrong. If it is moving, it will cover distance. I am not talking about displacement. If it is traveling continuously, it is going to cover distance. When the distance is covered, then average speed is distance by time interval. It will always be there. Correct. Okay. Next, 8th question. Velocity time plot for a given particle moving on a straight line is shown in the figure. Velocity time graph. See, velocity is decreasing here. Initially 10 meter per second, decreasing. At 10 seconds it has become 0, and after that velocity has changed its direction. So it is having negative velocity, meaning up to 10 seconds is going on one direction. After 10 seconds it is going in opposite direction. Okay, velocity direction has changed. Now he is asking about acceleration. What happens to acceleration? You see, acceleration is basically differentiation. Right, dv by dt. Acceleration is nothing but dv by dt. Okay, dv by dt is nothing but what? Slope. Slope of vt graph, and slope is constant if the graph is linear. Slope will be constant if the graph is linear, and that is why acceleration is constant. Correct statement, sir. Negative acceleration but constant. Particle has never returned ground. Particle has never returned ground, meaning how is it going? Never returned around. Okay, sorry, I don't. So yes, it is returning around there. You see here, at 10 seconds, just before 10 seconds it has got positive velocity, just after 10 seconds it has got negative velocity, meaning it has changed the direction. Particle has 0 displacement when? Always? No. Up to 20 seconds if you take, it has got 0 displacement. So up to 0 to 20 seconds it has got 0 displacement, but if he is asking about the total duration, right, it is not having 0 displacement. He said particle has 0 displacement for the entire journey. That is wrong. So this is wrong statement, but this is correct. It is going to, sorry, it has never returned back. That's wrong. It is turning around at t equal to 10 seconds. Average speed in an interval 0 to 10 seconds is the same as average speed in the interval at 10 to 20 seconds. That's correct, sir. So you have these congruent triangles. These two triangles are congruent. They will have the equal area. Area equal to distance. Area equal to distance. Area under VT graph equal to distance covered. Area under VT graph is equal to distance covered. Because they are congruent triangles. You see one common vertex and right angle triangle. And so they have to be congruent. That is why they will have the equal area. Equal area meaning equal distance covered. Area under VT graph will give you distance. In fact, velocity, if you take displacement, you see upper triangle will have positive area, lower triangle will have negative area, but magnitude wise both of them are same. So same distance are covered. Okay, next question. Figure shows the position of a particle moving in x-axis as a function of time. Okay, very good. The particle has come to rest 6 times. So yeah, rest meaning, how do you say? Rest meaning what is the condition? Mathematical condition. Rest meaning velocity has to be 0. Velocity has to be 0, but they gave xt graph. So when will velocity be 0? Dx by dt has to be 0, right? Dx by dt has to be 0. Dx by dt 0 meaning what? Slope is 0. Slope is 0. What are the points where the slope is 0? They are called critical points, or terminal, or otherwise stationary points. You see here, slope 0, slope 0, slope 0, slope 0, slope 0, slope 0. Local maximum, local minimum, local maximum, local minimum, local maximum, local minimum. How many are there? 1, 2, 3, 4, 5, 6. 6 times. Correct, sir? In the graph given, that is maximum speed at t equal to 6 seconds. So no, at t equal to 6 seconds, speed 0. Displacement is maximum, but not speed. The velocity remains positive from t equal to 0 to t equal to seconds. No, sometimes negative slope, sometimes positive slope, sometimes negative slope, sometimes positive slope, negative slope, positive slope. So downward graph, na? Decreasing graph meaning negative slope, increasing graph meaning positive slope. So x is decreasing, that means negative slope. X is increasing, positive slope. Decreasing negative slope, increasing positive slope. Decreasing negative slope, increasing positive slope. Whenever positive slope is there, positive velocity. Negative slope is there, negative velocity. So velocity remains positive from 0 to 6 seconds. That is wrong. B option is wrong and C option is also wrong. Okay. The average velocity for the total period is shown is negative. Oh, negative is it? That I need to check it. I have to. So, how do I tell? Do I have a scale here? Can I turn it? Is it possible to turn, sir? Okay, possible to turn. Now, this is the initial position. I'll use red color here. So this is initial position, sir. So initially you are here, finally you are here, meaning it has gone down. It has got negative displacement, correct only. Displacement is negative. Because displacement is negative, average velocity will be negative. D option correct only. 9th question is over. Next, 10th question. What happened? I'll remove this. How do I remove it, sir? Is there a way? I just have to, okay. So I'll just minimize it and get back to you because it looks like there is some problem with the loading. Now it has come. Okay, sir. The 10th question, that is the last question for the chapter. The acceleration of a particle as seen from two frames S1 and S2 have equal magnitude. Okay, relative acceleration, sir. So they are saying acceleration of P particle with respect to 1 is 4. Acceleration of particle P with respect to 2 is also 4. Okay, both are having same value. Then the frame must be at rest with respect to each other. Not necessary. One may be moving with constant velocity, other may be stationary, or maybe both may be moving with constant velocities in different direction. Still they may have zero acceleration. So when they have zero acceleration, with respect to each, it may have same, the particle may have equal acceleration. So particle must be at rest with respect, frames must be at rest, not necessary. The frames may be moving with respect to each other, but neither should be accelerated with respect to each other. That is also not required. Imagine one guy is going with each direction at 4 meter per second square and particle is at rest. With respect to this guy, particle has 4 meter per second square in opposite direction. And imagine other guy is going in opposite direction with 4 meter per second square. With respect to him also the particle is having acceleration 4 meter per second square but opposite direction. They didn't talk about direction, they just said magnitude. Yeah, so it's possible that I'm just trying to take a counter example. Imagine two cars are going in opposite direction. One person is stationary and both of them are observing him. They will see that he is having same relative acceleration but magnitude wise but opposite direction. That's okay. So frames may be moving with respect to each other but neither should be accelerated. That's also wrong. In fact, they can accelerate both. Acceleration of S2 with respect to S1 may either be 0 or 8. If they are going in opposite direction, it will be 8. If they are going in same direction, it will be 0. But that's not necessary. No? They can go in all possible directions. Why should they go only opposite or the same direction. They can go in this way, one can go corner, so it can't go upward. But in a horizontal surface, they can go in all possible directions, infinite possible directions. So it need not be only 0 or 8, it can be any value between 0 and 8. The acceleration of S2 with respect to S1 may be anything between 0 and 8, that's the answer. Yes, that's the answer you have. Okay, so with that I have completed kinematics, objective 1 and objective 2 questions. These questions are gems, diamonds, concept, pure concept. I think you need to revise them probably once again, second time, third time, until you are really comfortable with them. Don't say them, memorize them. Of course, don't try to memorize them, but you need to understand the concept and then memorize it. Understand and memorize. That's a powerful technique we have it. So with that, I'll conclude here for the day. I think we have taken around 1 hour, probably 1 hour 20 minutes I have taken for today. So tomorrow we're going to take up our next chapter. With that, I will conclude here. I hope you are able to follow comfortably. Try bring your friends also. Try to get them and make it a little more popular. So we have only 4 subscribers there. Let us increase the number. So with your support, I would get motivation. So I'd like to do it again and again. So hope that we'll be able to complete this HC Varma by end of probably by 2 weeks, 3 weeks probably. It depends on your motivation levels. If you want me to take more time, I can take it also. But again, students should be available. So anyway, I'll conclude here. Wish you all the best. We'll meet tomorrow. See you.